So we're now going to talk about the second part of the case study. This part's going to explore some other methods. In particular, it's going to focus on the do-on-error method and the map-not-null method. These are two operators that are interesting and a little different from what we've talked about before. And this time, we're going to use these to create, divide, and display big fraction objects synchronously. Once again, not the normal use case to do it synchronously, but we haven't talked about concurrency yet, so that'll come shortly. And as always, you can get this in my GitHub repository in the ex1 project in their active Flux folder in the live lessons repo. So now we're back in the ex1 project. Before, in part one, we took a look at the test fraction multiplication methods here. And now we're going to take a look at two other ones, test fraction division, error sync, and test map not null. And the names will give you sort of a clue as to what we're going to be talking about. So let's go over here and take a look. Here's where we left off before. We're now going to take a look at test fraction division, error sync, which gives you a hint as to what it's doing. First thing we do, as always, is we go ahead and create a string builder to store the results. Using these string builders, or as we'll see later, string buffers, are very important when you start doing asynchronous computations, because if you print things using the standard println operator, then when things are running asynchronously in the background, the output will be all interleaved in very strange ways. So here we create a list of big fractions, just like we did before. And I should probably start getting in the habit of doing this kind of thing, because I like that now, a little bit more concise. And now we're going to go ahead and do some interesting stuff here to trigger an exception. So we're going to use from iterable to take our big fraction list, and we're going to go ahead and basically log the results here. That's pretty much what we did before. But now we're going to do a different kind of map operation. Remember, map takes every element in that flux, every one of those big fractions, and does something to each one. And what we're going to do here, just because we want to generate an error, is we're going to take each big fraction and we're going to divide it by 0. Not a very good idea, right? Well, of course not. And you normally wouldn't write code like this, but you can imagine code where you bring in a number from a file or from the command line or from a user interface GUI window, and it turns out to be 0. So this kind of thing happens, so we have to be prepared to deal with it. So right now what's going to happen is we're going to use do-on-error. Now the semantics of do-on-error are sort of the inverse of do-on-next. What do-on-next says is run this code if all goes well, but don't run it if there's an error. And in contrast, do-on-error says run this code if there's an error, but otherwise don't do anything. Now in this particular case, I probably need to make this example more interesting, but in this particular case, we're going to end up with blowing up right away. I mean, the very first time we tried to divide by 0, we're out of here. And so what's going to happen is do-on-error will get called, and we're going to go ahead and log the exception. And after that point, we're done, and an error will be propagated up the stream. And so subscribe will end up basically just appending the error message into the string buffer, the string builder, and displaying it. This call here will not occur. This is the call that will occur, the one that's the error portion of subscribe. And of course, this code will not occur either. Now, in a more interesting example, we might wait a little bit to divide by 0. So you would see some things come through and be properly handled to the onNext event in subscribe. And then when the error occurs, we're going to print this result and then bail out. So I might need to update the example just a little bit to make that more clear. But at any rate, this example demonstrates what happens when you have an error, an exception. The next piece of code is also quite interesting. This illustrates the map-not-null method. So what we're going to do here is we're going to make ourselves our Flux using just, again, just for the heck of it. And we log the results. And now what we're going to do is we're going to use the map-not-null operator. That's a transformer operator that's going to propagate or emit any values that are not null. So how do we get something that's null? Well, here's what we're going to do. Again, this is a bit contrived, but just to make the point, you can see here we have numerators of 100 and various denominators, including one that is 10. And of course, when you create a big fraction that is a numerator of 100 and a denominator of 10, that ends up having the value of 10. If you remember your like 4th grade algebra stuff. And so what we're going to do here is if the big fraction equals 10, in other words, it was the one that was 10, we're going to return a null. Otherwise, we're going to return the big fraction. And what will happen here is if we return null, map not null will just ignore that value. So it'll only return the values that are not null. And that's good because returning null causes all kinds of problems for fluxes. They don't like nulls. They don't want to handle nulls. And then what we do is we print the results out, and you'll see when we run the program in a second that it'll end up basically printing out only the ones that are non-null when this is finished. So speaking of running things, we didn't really run the program before for part 1, but now that we have fewer methods to talk about, we'll actually run it. And you can see here, here's the output. Now, when these outputs run, they're going to print the results in the order that they were run, because there's no asynchrony happening. Keep that in mind when we talk about the other examples after we've introduced concurrency and parallelism, and you see that the outputs can come in different orders. So first one, test fraction multiplication sync. You get these results by doing the operations on big fractions. And you can see that test fraction multiplication sync 2 basically gets the same results, just prints out a few more bits of information. You'll see that so we get test fraction error sync, test fraction division error sync. You can see that it basically goes ahead and prints out the divide by 0 exception, because that's what happened. It blew up and didn't actually run. And then finally, we have test map not null. And you can see here that it emits the one that had the null and only prints out the 3 that were non-null. Whereas if you take a look at the other examples, you see that they print out stuff that was all of them, because we didn't have nulls. So that's basically what happens when you run the program. Pretty neat, pretty fun, and hopefully this gives you more of a sense of how to use the basic operators in Flux. We will talk later again, once we talk about concurrency, of how to do much more interesting examples.